Hello and welcome. Introduction. Now, in my previous video, in fact, my last video, I showed you how to interface or connect a 7-segment display like this to the ATmega 328, and we got that to count from 0 to F hexa. Now, my intention in this video is to show you how, in addition to this 7-segment, we are going to interface this push button switch to the ATmega 328. And the purpose of the push button switch is to get this 7-segment to count every time we push the button down. Therefore, we are manually controlling the count with this push button switch. More importantly, I would want to demonstrate something called a switch bounce from such switches like this push button switch. The hardware. Now, here is the schematic diagram, and basically I've taken from the previous video the 7-segment display schematic, and in addition to the 7-segment, as mentioned in my introduction, we are introducing or interfacing or connecting this push button switch to the ATmega 328, and this switch would be connected to a D8 on the Arduino Uno, which is also port B bit 0 on the ATmega 328. So here is the schematic. And here is the wiring diagram. And again, I borrowed this from my previous video, but in addition, this is the push button switch, and it's connected to D8 or port B bit 0 of the ATmega 328. The code. All right, so here the first 3 lines of the code are the directives. This directive here, they include avr/io.h. This is by default will be generated when you first start the project, and this is required if you are using things like DDRD and stuff. So this is required. You don't have to worry about it. As I said a few moments ago, is generated by default. And the second line here define the speed of the CPU. Then the third line of code, this include here, that is because this is required because we're using a delay function in the code later on. Right here is the main function of the code. In the first line here, I declare a variable called index, and this is used to refer to the elements of the array, and which brings me to this array, which I've declared as an unsigned char, and the array I've called it symbol, and basically the array consists of all the hex code to generate the symbols that is required for our program. Right, and here, this first 2 lines here, DDRD assigned with the hex code FF, that will make the port D as an output. And in the second line here, DDRB, I've assigned 00 hexa, that basically set port B as the input. And here I initialize index with the value of 0. We're starting with 0. And here is the code that will detect the switch So this line here, if pin and brackets 1, these two arrows with pin B0, basically this line of code here will check for the switch to see if it's pressed. I'll get back to this in a few moments if you're not familiar with it. So here index plus plus, this is actually equivalent to index equals index plus 1. All right, so that would use index to point to the next element in the array. And here we check if the array has reached 15. If it has, then we reset index back to 0. Then here, basically, we output the symbol to port D. Now, coming back to this code here that I pointed out earlier, basically this code here checks whether pin 0 of port B, to see if it's high or low. Now, if the pin is high, then we execute the statement index plus plus, which we have seen that earlier. Now, pin B reads data from port B. All right, so basically this will read from port B, and this here, if you're not familiar with it, basically this is a left shift, which gives, when this is executed, this will give, I split it up in into 4 bits. So 0, 0, 0, 0, 0, 0, 0, 1. Now, remember, it starts off with 0. I initialize it to 0. And the 0 bit turns into a 1 and this here will perform a logical AND on both this value and this value to check whether pin 0 of port B is high or not. Demonstration. Okay, so here is my AddMel Studio 7, and I put up the code here. And what I'm going to do first of all is to single step through this program with you. Now, in order to do that, I have commented out the delay, because this delay seemed to somehow interfere with the single step function. So so I commented it out. I still haven't found out why that is, but anyway, let's go through this program using the single step. So what I'm going to do is I'm going to build, clean the solution. I always like to do that, make sure that everything is correctly done. So right, so it succeeded, rebuilding it. So I'm going to debug, start debugging, and break. And what I should have done is have to, first of all, let me just clear this off. We don't need this. All right, and if for those of you who are not familiar with this watch, I'll show you how this is done. So let's assume that the watch is not set up. We go to Debug, Windows, scroll down. You see a watch here. We select watch 1. You can select watch 2, 3, 4, up to you, but I'll go for watch 1 here. All right. Usually this should be empty, but let's assume that it's empty. So what you need to do is double click on name. So I want to watch this variable index. So I type in index and enter. All right, right now it's optimized way with value and error for type. We will get back to that in a few moments. So let's go back to the single step. So here we start with the yellow arrow pointing here. So I'm going to use function F11 step function. So let's see what happens. So I'm going to do F11, initialize the array. Now, DDRD, the data direction port D. So I call it up here in the I/O panel. So select it. I should see DDRD. This line here should be all ones. Yes, we have FF. That will set up port D as output. All right. Now we go switch over to port B because we're going to do DDRB. Now we shouldn't see much here because it's all zeros. It's already zero anyway. Yeah. So index now. Watch index at the moment. It say unknown location. So what we're going to do is we're going to say now it's now registered with 0 and we're ready. Now, while we are now in a while loop. So for the first one, I'm not going to do anything with port B input yet. So I'm going to just step through. All right. So it's gone down because this is failed because port B pin B here is not pressed because this now represent this bit here now is the switch. Remember we use port B bit 0 as a switch, so nothing is activated here, so it's 0. So this part here will be skipped. All right, and now it's gone down and asked the question: is index greater than 50? If you look at index at the moment is 0, so it's obviously no. So it will skip this. All right. Right now it will then output symbol square bracket index square bracket. Let's go back to symbol. Symbol the first one element 0 is 3F. All right, so let's switch to port D. So port D here, watch it, it's 3F. All right, now before we get back to to this part here, let me just go to port B bit 0. Let's set it. All right, let's set it to 1. So that represents the switch now. Now, if you're doing this single step later on by yourself, make sure you set this 1 first before you return back to this part here. If not, it will not detect it until the next round. All right, so go back. All right, so now this pin here is now activated. So this now should be detected, right? So let's see. Yes. Let's assume that the delay has been executed. Now we'll check again that pin. If it's still down, it's still down at the moment. Now it will increment index by 1. Watch this part here. All right, so index is now 1. Here it asks the question, if index greater than 1, no, because we just got it to set to 1. So it will skip this one. Okay, so watch it. Now it will then fetch the next element in the array, which is 0, 6. This is index 1. All right, so we should see 0, 1 in port D here. All right, so port D. All right, so 0, 6. Let's go back again and do the next one. All right, check it. It's still on. Index 1. Now this will be 2. Just watch it go. Yeah, so we got pointer. Is it greater than 15? No. Now, so what's the third element in the array? So it's 5B. All right, so watch this change to 5B. Yeah, okay. So let's do one more. Okay, let's go back. And port B is still on, so it's still on. So it will increase index by another 1. So now index will go to the third one, which 3. The value will go up to 3, which is pointing to the fourth element, which is 4. Is 4F. All right, so Is this greater than 15? No. Now, it will then go to fetch this 4F, all right, as mentioned earlier, and go to port D. All right. Okay, so there's a whole list to go through now. So what I'm going to do now is to fast forward this thing until we get to the last one. So I'm going to like pause the video and get to the last element. All right, now index is 14. So port D is here. 14, if I'm not wrong, should be either 79 or 71. Let's see. Yeah, 79, which is this one here. All right, so we're almost there. Go back up, increment to the next one. Now it's so now is it greater than 15? Not yet. This is only reached 15, so this is still not fulfilled. Now the last element would be 71. All right, so so 71. Yeah, we got 71. Now watch this next time. So we the port B is still on. So watch now this value is 16. So we ask the question, is index greater than 15? The answer is yes this time. So watch it. All right, so now it will then reset index to 0. Yes, it does. Then go back, was index 0, port D. Now is this one 3F. All right, so watch this port D here. Yes, so now it's back to the beginning of the array. All right, so I'll conclude the demonstration here. Uploading the code. Okay, so let's try uploading the code to the Arduino Uno. To do that, just give me a minute. Let me just take this and I've got my camera on so that we can see this. Just a minute. See this? Right. All right. So the code is ready to be uploaded. So I go to Tools. Watch this bit here. It should start. This is because I've removed the RX line to enable the code to be uploaded. Remember from my previous video, because I've been using all the RX and TX pins on the Arduino Uno board, that seems to be interfering with the uploading of the code. So my short-term solution is to remove the RX line. Now that it's uploaded successfully, I need to reconnect the RX line to the Arduino Uno, and we should have a perfect 0. Yep. So we have that. Now, if I now watch what happens if I now press this push button. Now, the initial count is 0. So when I press the push button, I should see a 1. Because that's how it should behave, because the count after 0 is 1. So let's see what's happened. You see an 8 appear for a minute time, and then 7 appears now. Let me do this again. You see an 8 and then a 1. The counting sequence is totally out. Do it again. Now we have a C. We should see a D next time, but we got a B instead. Let's try one more time. and now we go back, we get a 1. Now the counting sequence is totally out, and this is the effects of the bounce of the push button switch. The solution. Now, a common method that is used to resolve the switch bound problem is to write a piece of code to check for a valid switch input. So this is the algorithm. So the first step is to read the port pin, as we did in the previous example, and then we wait for a few milliseconds and then check that same pin again. If the second reading confirms the first reading, then we assume that the switch has been depressed or pressed. So let's take a look at the code. As you can see, the code basically, this is the first half of the code, is basically the same as the previous example. Let's look at the second half, where in the while loop, we check for the port pin for the switch, and then this is where we delay, all right, make the delay and then check for the port pin again. If it's still pressed, then we do the index plus plus instruction. Now, the duration here all depends on the type of switch you are using. So I suggest you use a better quality switch. So you need to test the duration. So I don't have a formula for this determining the duration of this. So you need to try it out and figure out the best duration you can have for your switch. And then here basically it's the same as the previous example. When index is reached greater than 15, we reset the index to 0, and this part here basically we send the symbol out to port D. That's where the 7-segment display is. Uploading the code. All right, so let's try uploading the code to the Arduino Uno board. Before we do that, let me just clean the solution, rebuild the solution again. All right, now bring my camera in, and let me just remove the RX connection so that it won't interfere with the uploading of the code. So now let me just upload the code. All right, okay, so it's done it. So let me reconnect the RX line. Let's give me a minute. It's a bit fiddly here. All right, just a minute. Won't be long. Yep. Okay, so we succeeded in reconnecting the line. Right. So now now the initial count is 0, as we can see. Let me hold on to the board. Readjust the camera a little bit so that I can get a little bit more space. Now let's see this count go up when I press the push button switch. 1, 2. I think the switch is a little bit. I think. Okay, let's just try again. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, It should be an A now, because we're counting in hex. A, B, C, D, E, F, and back to 0. All right, so it seems the debounce code has worked and eliminated the debounce. Now, just a word. The quality of the switch also sometimes play a part in it. So I did have some miscount, but no big deal. So make sure you get a good quality push button switch for this. All right, so that's it for this particular part of the demonstration. Okay, so we have come to an end of this video. I hope you have found the contents of the video useful, and thank you for watching, and I'll see you in the next video. Bye.